Hello, it's Duncan. For a few weeks now, we've been looking at representing and manipulating data in Kotlin. We learned about lenses and how they can be used to lessen the pain of working with immutable tree structures. This week, we implement the same lens interface that we devised for working with statically typed data classes, but this time for the dynamically typed maps, I'm calling property sets. As usual, I had a rough plan for this episode, but that didn't survive contact with the code. See if you can spot the point at which I had an aha moment and everything becomes a lot more improvised. Let's remind ourselves what we're up to. We need to analyze some data, and that data is represented as JSON. And here's an example of it. And it's from the Google Places API, and it's the result of a search. And you can see the search has brought back 15 or so different places, and each one of those has some structure. It has a unique name thing, it has its type, it has phone number, and so on. And some of this data is primitive, and some of this data is an array, and some itself has more structure. And the usual approach for parsing data like this in Kotlin is to have data classes that represent this structure. And so we asked AI Assistant to generate those for us, and it came up with lots of classes. We had to fettle it a bit to make some of these things optional, but with not a great deal of work, we got ourselves in a position where we could do this. We can go to Jackson Object Mapper and say, read the data file as if it's a root, where the root has places, a list of place. So that is this thing here. And then a place has a name, ID, and so on. And with their structure, this list of address components, for example, that's a list. And these things here are address component, which have long text, short text, and so on. And so Jackson will introspect on this structure of the root and all the places and so on, and map the JSON into that. We had to configure it not to fail on unknown properties, because some of the places had properties that the example we gave to AI Assistant didn't have, but that's okay. And we also found that we can extend things like place with extension functions, or in this case, an extension property of country code, when we want to represent data that we can't find simply in the tree. There's another more flexible way of representing the data though, and I've been calling that a property set. But in fact, a property set is actually just a map of string to anything. Using this approach, we don't have to generate any types. We just ask Jackson to read the JSON as a map of string to any. And if we do, it'll create a set of nested maps or lists, where JSON arrays are represented as lists and objects with their own structure are represented as maps. And we wrote a little extension function required here that takes a key in the map and the type of thing that you think it is, and finds it and returns it. And in fact, there's a version that allows you to give a list of keys, where that would be something like places, name, types in the JSON. Now we can find our data just by navigating through maps, but if there's something we want to represent, like a place for example, we can create a little class here that wraps the map and is a map itself, and gives names to things like display name and country code, and specifies where to find them. So if we compare the two approaches side by side, the left one here is using strong types with a generated place. The right hand side here is using our property set. See, both start with an object mapper. Both use the object mapper to read. Just put that down there. In the case of the left hand side, we have a list of place. In the case of the right hand side, we have a list of property set. We pull the root out of it and then we map it into our place. And now this is our place type here, which only has the properties that we're interested in. That's in contrast to the generated version, which has lots and lots of properties, most of which we aren't interested in. The two approaches have pros and cons that I've covered in one of the episodes of this series. But today we're going back to the dynamic one, the property set version, to see if we can answer a question that we had about the non-dynamic version, which is how to update data. So for the strongly typed version here, we discovered we could use lenses to represent part of the data and use that to update things. So we could inject a new name into a place using a lens, and those lenses could be composed like this and built from a property of the data classes. That was last week. This week I want to see how to do the same thing with a property set. So I think I'm going to copy a bit of this, maybe that amount, as a test in here, and I'm just going to call this update. And we'll finish that off like that, and let's put those away so we can concentrate on this. So we don't want to use these lenses, but we do want a place to play with. Right then, the display name of our property set place is already looking 2 levels down, so it's looking display name text. So we don't need that, I think. We should just be able to do that, and let's run those tests. Good. Before we go on, let's just remind ourselves of the structure. So in our response, in a place, at the top level of the place, and it's here somewhere, find. Here we are, the display name. So you can see the display name is itself an object that has the text and what language it's in. And that's why in here, when we want to get the display name here, we say it's a required string and it's in display name, and inside that it's text. And there's International Magic Shop. So what if we wanted to edit that? Let's write something. We'll call it updated place is a place. Now data is immutable, so we can't just change it in place, but we could say with display name. And we could put new value in here. And what we'd like is that if that works, then the updated place's display name would be equal to new value. But just to be clear, the original place doesn't have its name changed. Well, that won't compile until we have one of these. So our options are now a member function or an extension function, and I guess a member function as we own this place here. So we'll call this value, and it's a string, but we know that we want to return a place. And we seem to have the wrong type there for reasons. Okay, so if we run this, it will fail because of this to do. There we go. And now our mission is to implement this function. Now then, a place is just a wrapper on the properties. So what we need really is to create some sort of new properties, which is our to do. And then we can return a place given those properties. Now these properties want to be exactly the same as the properties we already have, except that the display name property should have its text, but only its text changed. So what we can do is we can take our current properties and clone them. And we can do that with toMap. So properties is already a map, and toMap, you can see here, clones it. But somewhat ironically, in the case of more than one item, it does toMutable map, but returns it as an immutable map. Actually, for us, it would be a lot better if we used a mutable map. So let's go back, and we'll change that to toMutable map. Now we can affect this properties without changing this one. So what we're going to say is we're going to say new properties, and with the key display name, we're going to put in a new map. And that map is going to be a clone of this one. So let's write it out in longhand. So this is going to be new display name. I'm going to call it node for want of a better name. That is going to be new properties at display name. Now that's any, but we know we need to cast it to a property set. And once it's a property set, we can make that a mutable map too. Now we can take the new display name node, and its text needs to be the new value. And now the new properties at display name we're going to substitute with our new display name node. I think there's a chance that will work, so let's give it a go before we tidy up. Oh, but this is live television, and the issue is that we are not using new properties in there. Let's try again. Phew. Now then, this new properties display name as property set is in fact just required display name where we tell it that we want a property set. So that we can get rid of that. Good. And now we can work a little apply magic to tidy this up. So if we apply here, then we can pull that up into there and say that is this. Now we can inline that. That's still good. It is. And now we can do the same again. We can say apply, because move this up. And in there, that is this. And now we can inline that. And fix it all up a bit like that. Good. And I suppose we should just check that we haven't nuked this language code. So we should also check that a place, now we've never cared about the language code, so we don't have a mapping for it, but we can do that with a place required string at display name language code is equal to n. And when we're done, updated place should have the same. And does. Good. Now, if you've been following this series so far, and if not, what on earth are you doing here? I think you recognize the sort of pattern here that we had with the data classes. That we need to copy a thing, changing one part of it, where the thing that we change has only one part of it changed. Now, with data classes, we solved that problem by composing lenses, and I'm wondering whether we could do the same thing here. Let's go and remind ourselves what that looked like. So here we created two lenses. One was place display name, which represented this. And then there was display name text, which represented that. And then we composed them together with display name and then text. So, and to be honest, I'm winging it a bit here. Can we do the same thing for our property sets? Now, I can't honestly see how to refactor this that way. So let's just try writing the components and see if they work. I'm going to make this a block body. And then I'm going to say from here, what we want is 3 lenses. So I'll copy that and put it into here. And the types are all wrong now, but the first thing I want is going to be a lens. And the subject of the lens is going to be a property set. And display name has things inside it, so the thing we're going to extract from it is a property set. We'll come back to how we do that in a minute. Now the text, well, that is going to be a lens that takes the property set from display name and returns a string. And we'll worry about that in a minute. So we can build a lens out of a getter and a setter. So let's do that. We've got lens object, and that takes 2 things. It takes a way of getting this property set from that property set. And in this case, the display name is going to be this required property set display name, effectively. So I think if we put that in here, we can say that that is the parameter to our getter, which is it. And we want to get a property set from that that has the name display name. And our injector, well, that, we'll go back to lens and just remind ourselves, an injector takes a subject and a value. So the subject, value, and that's the code we've written here. So it's a required property set to mutable map, apply, and then that map we can change with the value. So in here we can say this, given the key of display name, equals our value. And the subject is the subject. Now we're not compiling very well. Let's have a look. It says it can't infer the type variable t. Well, maybe if we give it a hint here, that will help. That's good. Oh, in fact, that seems to be almost good enough completely. What's our issue here? Expecting an element. Don't know what element. I don't think we've closed this brace. We've got one for the apply here and one, so that needs to be like that. Reformat, and that will make things clearer. So what we've done here is we've taken the get, which is this display name bit here, and the injection is kind of this bit here. I'm really winging it a bit, to be honest with you. Let's try writing text in the same way. So it looks like we didn't need one of these. Let's get rid of that one because it's the obvious bit. So let's write text. text is going to be a lens that takes a property set and extracts a string. So we can do that with two lambdas, and they're going to look very much like this. Copy that one into here, but now the required thing is a string, not a property set. So we'll do that. And this one though wants to be, the name wants to be text. So we'll put that in there. And the injector wants to look very much like this, but we'll write it from scratch. We'll say injector is a lambda that takes a subject, the value, and again we have to take the subject to mutable map, and then I don't think we actually need it apply. We can just set the thing at text to be our value. Issue here that this should be lens object. Oh, and we did need the apply because we need to be returning the mutable map, but as a non-mutable map. So that is dot apply this text equals value. One more of those, and that compiles. And now, due to the lack of symmetry, I'm reasonably convinced that I don't need to do this bit here. I think that's one level down too far. So that those should look the same. Okay, so far I've just been winging it. The question is, can we use this display name text now? We should be able to use it to set the display name text. So in other words, we should be able to say val new properties is this dot properties, and we should be able to take the display name text and inject into this dot properties the new value. And then that should be the equivalent to all that, and we should be able to put new properties in there. This will be interesting, but it does work. Now, if you follow the channel, I think you'll know what's happening next, and that is we're going to take this thing and make a method out of it. So lens object will be fine for now. And now we're going to say this should be parameterized by this text. So we'll make a parameter, a lens object, and that is our property name. Check that works. And it does. And now we could use that in here, were it not for the fact that this is required string and this is required property set. So let's just take this out of here and move it to the top level so we can check that it doesn't require anything for the tests. I'm just going to tighten all that up a bit. And now this is a type, so we're going to extract it as a type parameter. Now there are two of those in here. Let's have a look. This property name always wants to be a string, so we're going to skip that one. But the lens object wants to be of this t, so we'll replace that one. And now we have a problem that we can't use the t here, but we could if this was an inline fun reified t. Check that. Is good. We don't need the t to be string, but we do need it to be any because we are always requiring these things exist. So I'm going to make that t is any. And we've called it t here, but in other places in lenses, that's been our r, the thing on the right hand side, the thing that a lens extracts or injects, not the thing it extracts or injects into. So I think we will rename that to be r. And now we can use that lens object up here in place of the display name. So this is lens object. The thing it's going to return is a property set. So it's going to take a property set and return a property set. So it's there. And its name is going to be display name. Run that. And we're good. And now then, I think if we were to inline that and that, then we could bring this to the top level as display name text lens. That I think would be private in here. We can inline that, make that an expression, all good. But now also the display name here, previously we were doing this required taking of var args. we'll now work in terms of our display name text lens. So we can take our display name text lens and apply it to this, which is a property set, using its get. Is that true? Yes, it is. Maybe we could tidy this up a bit by moving that separately, and maybe that up there as well. That under with display name, and check we haven't broken anything, which we haven't. I'm going to be brutally honest and say this has gone in an unexpected direction for me. I know I was looking for lenses, but I didn't expect them to sort of pop out this way. As a result, I don't really know the relationship between this place type here, the one that encapsulates properties, and the lenses that it's using to extract. Do we need this thing anymore? Could we just work in terms of lenses? It seems for complicated things like this here, where we could write that in terms of a lens, but it would be hard work. And I think certainly we'd want to be able to create a lens that could only extract and didn't care about injecting. I really don't know. Other things I'm not sure about, well, one of them is that the relationship between this required here, because it's required, it means that T can't be nullable, which is why we've got any here. It seems to me reasonable that we should have a lens that could extract something that is null, but I don't know whether lens object is going to have to ask the question whether R is nullable or not. Don't really know where that's going. Also don't know what should happen if you try and set display name text, but the initial property set doesn't have a display name. Should it create a display name that's empty and then add text inside it? Again, I'm just winging it because I really didn't expect this to turn out this way. Well, one of my heroes was Tom Lehrer, and he used to say that if people couldn't communicate, the very least they could do is to shut up. So I think I should take that advice and finish here, and pick up again next week when I've had a chance to digest the ramifications. If you'd like to see what I come up with, then please subscribe to the channel. Like this video, unless you didn't. And remember that nothing says I love you at Christmas as well as buying your mother a copy of the book that I wrote in that price, called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.